Okay, getting started. Under 2-1, we are going to mention that we have two new power sources that are being added to the low volt standard. We are all familiar with battery systems both for the chassis and the house. We are familiar with converters and inverter chargers. And we are also familiar with the charge line from our tow vehicles as well as other power sources that are listed under 2-1. The first new power source being added, we all know well, solar panels. These can be permanently mounted or portable units that are set up once you are at the camping location. The second and much more obscure power source is the fuel cell. To date, I have yet to see a fuel cell installed in a production line RV. Fuel cells work like batteries, but they do not run down or need recharging. They produce electricity and heat as long as fuel is supplied. A fuel cell consists of two electrodes, a negative electrode, or anode, and a positive electrode, the cathode, sandwiched around an electrolyte. We may not see them yet, but we're sure that the day will come, so in anticipation, fuel cells have been added to the list of power sources in the 12-volt standard. All right, 2-3, and this is on non-vented battery installations. First, non-vented batteries need to be listed. However, a specific standard has not been chosen as this technology continues to develop. So any listing provided for the battery would need to be a listing agency that is on the RVIA recognized list of acceptable listing agencies. Installation instructions should be provided by the battery manufacturer or supplier, and they need to be followed. Often, these instructions will dictate that batteries installed outside the RV need to be placed in an enclosure, a housing, or a hood. This is typically to protect the battery and its connections. Now, if the battery installation instructions do not address installing inside the RV, it will be required that the battery terminals be protected from unintended contact with goods or other components. This would permit shelves or other such protection to be added to protect the battery from that physical damage. The following warning label also needs to be affixed in multiple locations as follows. First, one needs to be affixed to the RV adjacent to the non-vented battery in a location that remains visible after the battery's installation. Secondly, a label needs to be affixed to the battery where an enclosure is not provided, or to the exterior and interior of an enclosure when it is provided. And finally, lithium batteries are required to be listed, which does address thermal runaway. They are also required to have a management or a protective system to provide safety for situations of high or low voltage, high and low temperature, and for limiting high current output, as well as for cell balancing. All right, let's take a look at the requirements for solar preps. Most of this is common sense, as you would expect, and there's really no departure from the normal installation of 12-volt components. The first requirement is based on following long-established requirements. Since there will be a wide variety of configurations when solar power is installed or in a prep form, it must be remembered that these solar panel installations are part of the low voltage system. As such, they need to comply with all applicable requirements of the low volt standard. As seen with these deviations from the low volt standard and our RVIA deviation database, these codes related deviations are well known in the RV manufacturing facilities. These and other deviations under the same code references are to be considered when installing a solar power system. So the best way to look at the first requirement of 2-6 is that all solar preps must follow the applicable requirements of the low volt standard. The second requirement states that if you install the solar controller, it must be installed as required by the manufacturer's installation instructions. This requirement goes along with the installation of most devices on an RV, that they must be installed as the manufacturer of the device intended. Installing them in a location other than where the manufacturer's installation instructions require can void the warranty and potentially create a dangerous situation for the occupants of the RV. The third requirement. This specific requirement states that either end of the conductors involved in the solar prep be capped so there are no exposed ends of the conductor. When a solar prep is installed in an RV, the conductor ends must be capped with no exposed strands. This is an example of what would be considered an exposed end or exposed copper conductors. The use of junction boxes will still require that the individual conductors be capped within the J-box. Solar preps will vary in how the conductors are installed, but the bottom line is that conductors must be capped and labeled at either end of their run when necessary. The next requirement, number 4, is that conductors are retained within the identified controller location. What does this mean? This requirement means that securement must be provided for the conductors at the specified controller location if the controller is not installed as part of the solar prep. Conductors are not to be loose within the cabinet or other storage location intended for the controller's installation. Number 5. Now we are going to look at the labeling of conductors involved in the solar preps. The controller shown here is highlighting the positive and negative connections to the battery bank. However, on a simple solar prep's installation, the controller may not be part of the prep. In that case, only conductors may run from the installed roof connection back to a junction box where the controller will be installed sometime in the future. In that case, and at that junction box, labeling will be necessary. At this location on the controller, if installed as part of the solar prep, the battery connections are labeled with a battery icon displaying both the positive and the negative designations. So additional labels for battery plus and battery negative will not be needed if the controller is clearly marked as seen here and installed as part of the solar prep. If only a junction box is provided or conductors simply secured to the future controller's location, then the positive and the negative labels must be attached to either the conductors themselves or to labels adjacent to the respective conductors. Here, the controller clearly designates the positive and the negative pressure connectors that would be acceptable labeling if installed as part of the solar prep. So the sixth requirement also deals with more labeling. Again, this labeling requirement will vary from system to system based on the overall design configurations. These labels may be attached to the appropriate ends of the conductors at each terminal of the battery or battery bank connections. They also may be attached adjacent to the connection terminals of the battery bank enclosure or compartment. The seventh requirement again is a labeling requirement. This is for the solar power input at the controller. Here again we see a solar panel controller with a solar panel icon and a positive and negative indication on the controller itself. This would be appropriate if the controller is installed with conductors all the way to the roof connection terminal. However, if only wires are supplied from the roof connection or other connection location, such as a sidewall mounted solar panel connection for mobile solar panels, then a labeling at the solar controller's location must be supplied. If a roof connection terminal, as seen here, is provided for a future solar panel, the other end of the solar prep conductor seen here would run back to a controller as mentioned in the previous slide, or to a junction box or a set of secured wires at the future solar controller location. So at this point, if a controller is not provided, an additional label will be needed on each of the conductors, identifying them as positive or negative leads respectively with a PV plus label or a PV minus label. In summary of 2-6, simply remember that all applicable low volt standards apply to any solar powered supply system, as they would with any other 12 volt equipment or material. Then apply all requirements to 2-6 listed here for a properly installed solar prep system. Okay, on to 3-1. This is an exception to 3-1 along with braking circuits, cranking circuits, and circuits supplying FMVSS required lighting. Solar panel circuits are considered current limiting. Therefore, overcurrent protection is not required of these circuits, providing the conductors have sufficient ampacity for the largest available current from the solar panels. To date, and in my experience, supply conductors leading from the solar panels to their controllers have always been a 10-gauge stranded wire. Stranded because it's a current carrying and it's in the low voltage system, a specific requirement for the low volt standard under 4-1. The use of 10-gauge conductors is not necessarily the largest conductor that could be utilized, but it is the primary conductor used for this purpose at this time. When evaluating the installation of any solar panel and its associated components, always refer to the manufacturer's installation instructions to assure that the proper conductor size is installed. This should also be based on the maximum current the solar panels can produce in conjunction with the ampacity rating for the stranded conductor to be installed, normally a 10-gauge stranded conductor.